students, our next topic is telescope. Here we will discuss about refracting type telescope and reflecting type telescope. In telescope, that is refracting type telescope, I am going to explain first. Here also we have an objective lens and the eyepiece lens. But here the focal length of the objective lens is greater than that of eyepiece, and the diameter of the objective lens is so greater than the eyepiece. You know that telescope is used to see the very far objects. Here we are discussing only astronomical telescope. See, the rays are coming from infinity. It converges at the focus of the eyepiece. Here, the angle subtended by the image at the eyepiece, that is theta I, and the angle subtended by the object, that is theta O. Now we know that the magnification is the ratio of angle subtended by the image to the angle subtended by the object. Here h is the height here. See this distance is Fe, that is the focal length of the eyepiece, and this distance, that is Fo, that is the focal length of the objective lens. Here you know theta I means h upon Fe, and theta O, that is h upon Fo, that is magnification of the telescope, that is Fo by Fe. Now see the length of the tube. The length of the tube, that is capital L, that is equal to Fo plus Fe. That is the length of the tube. Now, why we want to go for a reflecting type telescope? What are the drawbacks of this refracting type telescope? See, for getting the clear image, the diameter of the objective should be large. If you increase the diameter of the objective lens, what happened? Then the lens become very heavy and it require more materials to make, and supporting very heavy lens, it is very difficult because you can support it only on its rims. Now, if you increase the thickness of the lens or diameter of the lens, if you increase the diameter of the lens, what happened? The lens should have some type of aberrations, that are the defects of the lens. That means there are two type of aberrations are there, that is spherical aberration. What is spherical aberration? You know that the rays which are very nearer to the principal axis, that are called paraxial rays. Away from the principal axis, that is called marginal rays. Here the paraxial rays and the marginal rays, it will not meet at the same point. It will meet at a different point. That means you will get a distorted image. That is spherical aberration. The same way, the thickness of the lens is more, then the lens produces dispersion. That means you will get a different color images. That time also the clarity of the image is reduced. That is chromatic aberration. So these all are the drawback of the refracting type telescope. To increase the performance of the telescope, you have to increase the diameter of the objective and the focal length of the objective lens. To increase the diameter of the objective lens, that means it can have this type of aberration. So to reduce this, we will go for a reflecting type telescope. In reflecting type telescope, in place of the objective lens, we used a objective mirror. Mirror is free from all type of aberrations. So the aberrations, that means the defects due to the aberrations, is minimized in reflecting type telescope. Let us see what is the ray diagram of reflecting type telescope. This is the ray diagram of reflecting telescope. Here we use a paraboloidal mirror. That means this is a type of concave mirror only. The rays incident on the objective mirror reflect back. Here secondary mirror is there. Then this secondary mirror reflects all the light rays and all converges at the eyepiece. Eyepiece is a lens. In place of that objective lens, we use a mirror. So spherical aberration and the chromatic aberration is minimized. If it is a mirror, so you can give support from the back side also. So this is the reflecting type telescope. Say this advantage of reflecting type telescope over the refracting type telescope is given here. This is very important, you learn it.